Hello everyone! It's me again, Teacher Joanne. This tutorial is for statistics and probability, a subject which is intended for grade 11 senior high school students in the Philippines. For today's objectives, at the end of the lesson, the learners will be able to illustrate the central limit theorem, defines the sampling distribution of the sample mean using the central limit theorem, and solves problem involving sampling distribution of the sample mean. So for today's lesson, we have the central limit theorem. So what is a central limit theorem? So central limit theorem states that as the sample size increases, the distribution approaches the normal. So the accuracy of the approximation improves as the sample size gets larger. So that's according to Spiegel and Stephens 2011. And regardless of the population shape, the shape of the sampling distribution of the mean approximates a normal curve. So if the sample size is sufficiently large. So that's according to Witt and Mead 2007. So meaning that when the sample size increases, so it actually approaches the normal. So that's what the central limit theorem states. So a sample size of 30 or more is considered a large sample size. So if this large sample size is taken from a population with mean and standard deviation, then the sampling distribution of the sample approaches the normal distribution with the sample mean equals the population mean. And the standard deviation divide the square root of the sample, thus can be standardized as, so we have the formula, z equals, so x minus the mean divided by the standard deviation divided by the square root of n. So example number 1, the height of the pupils in Dasmariñas National High School, Senior High School, has a mean of 145 cm with a standard deviation of 5. If 60 are taken as samples, what is the probability that their mean weight is less than 143 cm? So we're looking for the probability of x is less than 143. Then using the formula, z equals, so x minus mean divided by standard deviation divides square root of the sample. And then just substitute the values. So we have 143 minus 145 divided by 5 over square root of 60. So this will give us negative 3.1. And if we look it up on our z table, we will have 0.0010. So therefore, the probability that the mean height of the sample is less than 143 cm is 0.0010 or 10%. So we have example number 2. A certain internet poll reported that the average time of women spent in the bathroom is 75 minutes with a standard deviation of 4.3 minutes. If the times in the bathroom are approximately normal, what is the probability that the mean time for 20 randomly selected women exceeds 73 minutes. So we're looking for the probability of x is greater than 73. So using the same formula, so let's just substitute the value. We have 73 minus 75 divide 4.3 over square root of 20. It will give us negative 2.08, which is equivalent to 0.0188 if we look it up on our z table. So if you remember, so if it's greater than symbol, so we actually subtract the given area or the area that we have found from 1. So the probability of x is greater than 73 is equal to 1 minus 0.0188, which is 0.9812. So therefore, the probability that the average time of the 20 selected women exceeds 73 minutes is 0.9812 or 98.12%. Next, we have example number 3. The mean score in midterm exam for probability and statistics of grade 11 students at Dasmariñas National High School, Senior High School is 45. There are about 60 students selected and found out that the standard deviation of their score is 6. So what is the probability that their mean is between 43 and 47? So we're looking for the probability of x is greater than 43 but less than 47. So using the same formula, so z equals x sub 2 minus mean divided by standard deviation over square root of the sample minus x sub 1 minus the mean divided by standard deviation over square root of the sample. So our x sub 2 is 47 and our x sub 1 is 43. Then just substitute the value. So 47 minus 45 divided by 6 over square root of 60 minus 43 minus 45 divided by 6 over square root of 60. And it will give us, so two values, 2.58 minus, so negative 2.58. So first, we look for the equivalent of 2.58 on our z table and then negative 2.58 on the z table before we subtract the 2. So it will give us, so 0.9951 minus 0.0049. So the equivalent of 2.58 on the z table is 0.9951 and for the negative 2.58 is 0.0049. Then we subtract the two values, we would have 0.9902. So therefore, the probability that their mean is between 43 and 47 is 0.9902 or 99.02%. So we're done for today and thank you very much. I hope you learned a lot and see you in our next lesson. Bye!